Good afternoon to all. I'm very happy to share with you our experience in a real fire core in Italy. I represent here two companies. Tecnologia Ricerca Rischi is an Italian name, and Romano Safety Management are two companies that perform this analysis. Just a few words about our company. We are a private company that operates in the risk analysis sector. Our service, the main core is about the industrial risk analysis, and we operate in mainly oil and gas sector, and petrochemical sector, but also in other industrial sectors such as iron and steel industry, chemistry, and so on. I'd like to present our experience in this real fire core in a waste treatment plant last year. Consider that in Italy, unfortunately, we have about 300 similar fire events. And the scope of this intervention is to present a fire modeling in order to establish if the sequence of the events that we collect about operator interview, local authorities report, and so on, was suitable and compatible with the developing time of the fire event. Finally, results from the simulation have been compared with the information, evidence collected, and so on. So this is the summary, 5 points. So the first part that I hope is the most interesting part is the fire event description with the all data collected and information register. Then the fire data collection, some feature about fire modeling, and then we have some conclusion about the investigation and some future development, especially by considering our experience in Italy. This was the fire, of course. Sorry. This is some image as a courtesy of the fire brigade department. This was the event. The critical point is that this warehouse was very near to petrochemical plant that obviously have some storage, flammable storage. So the evolution of the fire has been critical in these terms. We have no victims, fortunately, but the event fire duration was about more or less 5 hours. The warehouse is not very big, 3,000 square meters, about 12 meters as height. In this warehouse, the owner of this plant, the material that come in this plant arrive from immigration point center. So we have, as we can see later, mattress, wood, very type of materials. This is the layout before the fire. This characterization was built with a person interview after fire event. Very important, the fire brigade and the local authorities official report, and management information interview after fire event. This is the very simple layout. We have many types of materials, so mattress, wood. Triturate means that comes from the triturated machine that works on the center of the warehouse. And this box we had also triturated materials, and in the compartment 7 other materials, various materials that they storage here. Very important, there was a tire box outside the warehouse, and this is a very critical point that I show in the last part of the presentation. So with the red color, I try to show you the information that personnel and local authorities give us in order to try to simulate the fire events. Operators say that in official report that they see ignition near the triturated machine, so probably due to the mechanical movement of this machine. I have some photo that I can show you later. After more or less, consider that these are interviews, so it's not very precisely, but more or less 3 minutes the ignition near the machine. We have the starting of the fire to the compartment 6. And after more or less 5 minutes, we have the ignition of the other compartments near. This is our very simple sandwich panel. At more or less 3 minutes, the internal emergency team arrive here. Consider that we know we don't have any fixed fire system, no passive protection, so they try to extinguish with fire extinguisher, but they don't try to extinguish it in the first seconds of the fire. Person interview says that we have some flames in this tire box in the outside of the warehouse. After 10 minutes, about personal interview, we have also the fire, the auto ignition of the mattress here. And after more or less 10 minutes, external fire brigade arrived to the local department in order to help the internal emergency team. We have some hydrants outside the warehouse. Then after more than 10 minutes, we have fire in all other compartments, and probably after 50 minutes we have the flashover of the entire warehouse. So the 3 questions that we discussed in this analysis was about if the fire in the warehouse was congruent in terms of propagation speed and intensity. The second answer was about, the second question about the fire in outside container with rubber and tire box was suitable with development of the fire inside the warehouse because the owner of this warehouse supposed that it was a third-party ignition outside the warehouse. And this is another phase of the job that is still running, the causes that led to this fire. So this is, we just speak about the layout, some details. We have a conveyor belt between the compartment 6 and tire box. This is a 3D model that we create with PyroSim. More or less just a quick dimension, 100 meters, more or less the length of the warehouse, about 25 meters wide. Compartment 6 is about 6 meters, 8 and more or less 10 meters wide. This is the tire box. We choose only one tire box there are many caissons outside the warehouse. We choose it, this one. Okay, these are some material parameters during fire modeling. We details in our paper all the reference, mainly from NIST, and in particular to rubber out ignition temperature. We receive some details from the owner because, as you know, there are many types of rubber, so we consider 400 degrees as an out ignition temperature. These are some main characteristics about the simulation. We choose FDS and PyroSim interface in order to simulate the fire event. With our machine, we need about 100 hours, more or less, with the pyrolysis activated. And so we use a 8-core machine. We choose to represent for you with 2 video because probably it's more easy for me to show you. The violet is a network that prevent the pigeons because they have some problem inside the warehouse. This is more about 3 minutes simulation, and we see that the modeling. The modeling reply in a very better way. We choose obviously the start of 5 years, and then we have the 2 treated materials here, and more or less at the same time, this is our, as you know, virtual wall where we represent temperature. Very important for our analysis is to see that outside the wall, outside the warehouse, more or less the temperature in 5 minutes is less than probably 200 degrees. So these are the 3 questions that we see before. The first question was, is the fire in the warehouse was congruent in terms of propagation, speed, and intensity? In our opinions, the answer is yes, because we have many evidence about this point. This is the time, I remember you that this evidence is collected by operator interview. They say that more or less 200 seconds the fire was extended to the compartment 6.6. So the fire go from here from here. From the modeling, we find this very amazing result because more or less we have 147 seconds and 200 seconds is very similar for this situation. So the fire comes from here and propagate to the compartment adjacent. Another evidence is about 5 minutes. Operator says that the fire was extended to compartment 1, the mattress that is this box. And also in this case, it's a very amazing results that 300 seconds, 322 seconds, we have the flame as ignition of the mattress site here. And finally, another very important comparison with real fire and modeling is about at the end of the fire. This is as courtesy of the fire department, more or less 1,000 seconds, all the flame was extinguished. The warehouse don't collapse, so the structure maintains, and this is also compatible with the results we see always with the temperature profile that they were in the wall. We don't achieve more than 300, 400 degrees. For what concerns the outside box, in our opinion, the answer was no, because if you see, this is the image after fire events. We have the box, the tire box is obviously is evident that was burst, but in the modeling, in the fire modeling, this box is not suitable because more or less we have 200 as maximum temperature. This is not sufficient to create ignition of the rubber. Another key point is that from the fire in compartment 6, we have more or less 10 meters from the wall. the tire box is outside. Between compartment 6 and tire box, we have conveyor belt is made by the same material, so we can't explain as this was in fire and this was not in fire. For what concerning the causes, as I explained before, this is still running, this investigation. Probably these are two photos of the shredder waste and the machine. Probably one of the hypotheses is a flame rocket that come here. As I told before, in this warehouse, treatment plant arrives material from immigration points, so it's reasonable that material from ship comes in this waste. Further investigation show us that in the waste treated, we have many type of materials. We have some plastic bottles, water bottles, probably also flammable materials. So this could lead to the fire ignition of the triturating machine. Last two slides, we would like to share with you some further development. As explained in the premise, in Italy we have in last 3-4 years about 2,065 events, 200, sorry. And for that reason, 2 months ago, Italian Ministry of the Environment has issued a first based on a guideline for this type of plant. In this guideline, the Ministry of Environment asked a revision of fire prevention criteria. As we can see, we have no active fire protection inside this warehouse. Also, fire management had to scale up. And last slide is another case that is still working in this month. This morning, Brian speak about BIM, Building Information Modeling. Also in Italy, in industrial sector, begins this process. This is could be a typical workflow. Also for fire investigation, it's very circular way, because from laser scan we arrive to our 3D cloud modeling, and in order to arrive at point cloud 3D that can give us many information about fire risk analysis, and then we can create our model, CAD model, that could be imported in PyroSim for fire simulation and so on. Consider that this is a full workflow for existing warehouse where the owner probably, in many cases, doesn't have plot plan information about materials. So thank you very much to Thunderhead staff and to you for the attention.